Oh. Real quick, the numbers here are wrong. When I had this printed out, I had to look at the wrong columns or grades to make corrections. I curved it, so these are, I had to look at the wrong column. But everything else is right, so make sure that everything else looks okay. Sure. All right.
I got the little candles for your channels. Oh, look what's coming. Sort of, yeah. Before we get into elimination, a real quick substitution. Want to make sure everybody's on the right track with that. Ooh. This is page 91. I'm just going to do this one problem real quick as a review. As a review of the substitution method. Hey guys. So page 91, number 3. It's a nice, good, big sigh. I like that. Oh my gosh. Math class. Alright. So the idea with substitution is actually really kind of nice if you let it be. That first equation is fantastic, because what's that first equation tell me? Yeah, I know what y is. Y is x minus 5. So when I see the second equation, I'm going to make it better. I'm going to use the information that I just gleaned. Ooh. I'm going to rewrite the second equation using what the first equation told me. So I can rewrite the second equation as 2x minus 5 times y, but y is x minus 5. So I rewrite that equation, plugging in what the other one told me. Now, if you don't, if it says use substitution method and you don't have an equation that has a letter solved for, then you do that. And how do you pick what letter to solve for? The one that has no coefficient, has a 1 coefficient, if there is any. Because then you won't make any fractions, because you don't have to divide by anything to solve for it. Does that make sense? So this one's kind of nice, because it was already solved for y. Bodacious, right? If it wasn't already solved for y, I'm trying. If it wasn't already solved for something, then you just pick the one that's got a 1 coefficient, solve for it, so you don't bring fractions in when you don't have to. Does anybody any questions over what I've done so far, which is not much, but is the fundamental idea of what this thing is all about? So this is sort of a lot. All right. So now I've got an equation that's only got x's in it. I can actually solve it. It's a better equation than either one of these because there's less unknowns in it. So I get 2x minus 5x plus 25. So I get negative 3x. I can subtract 25 and get 24. Divide by negative 3. Man, I'm really writing well today. X equals 8. Holy shit. And the really nice thing about substitution method is you're always going to have one of the equations already solved for the other letter. So if x is 8, y is 8 minus 5, which is 3.
Eight.
Second?
I was just writing it in 8 comma.
Oh yeah, good. You love it. So the slightly better way to write it is 8 comma 3 because the answer to a system of equations is the point or points where the two lines would meet. I didn't graph shit up here, but if I did, they would meet at 8, 3. I love it. If you don't write as a point, you're not dead. Just circle the x and the y is still right. There we go. Right. Okay. So that's substitution method. We've done quite a bit of that. I just wanted to make sure everybody's up to speed on that. Let's talk about the next type, and then we'll probably get a little bit into word problems, and then we'll head out. Elimination. Now, I don't know. 83. Oh my God. Now sometimes you get taught this method and the instructor doesn't really talk about the weirdest part of this, which, I don't know, no students really ever ask me this, but I gotta wonder. You're not allowed to add different things to two sides of an equation, right? You can't add 7 on one side and 5 to the other side. You with me? All right. So the whole idea behind elimination, though, is I can add two equations together. So part of your brain should go, what the shit? What? So if I added 8 and 4, so I'm adding 4 to this side. 4 and 8 is 12. I better add 4 to this side also. But isn't 4 equal to x plus y? That's what that says. 4 is x plus y. So if I add 4 to 8, I can then add x plus y to x minus y. And what's really kind of nice about that in this problem? The y's die. I love it. Or they cancel, if you want something less violent. So what do I get when I add these together? I get 2x. The y's cancel. That's not so underhanded as substitute. Substitute goes, ha 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 ha. Right? This is just directly done. Which might be why I like it better. I don't know. I just like to directly kill it. And then
Put it back into.
So divided by 2, x is 6. All right, let me stop there for a second. Now, obviously, we have to talk about, this was really nice because the y's are already opposite signs. They have the same coefficient. You guys, so that's nice. Well, so then we got to get into what the hell do we do when that's not true. But the fundamental idea is I can add equations together because I am adding the same thing to both sides. I add 8 to that side. 4 to that side. X plus y is 4. So I add x plus y to that side. I've added 4 to both sides. Maybe. Now, am I done with this problem? No. How do I figure out what y is? I'm going to use this one because the y is positive in that one. So I know x is 6. So now I know y is -2. So that is fine as an answer. But in addition, you can write 2. Thank you. In stereo. I like that. Good, you work. Yay. To run out of my green ink. All right, you guys try number 2. Real quick now, a few more people might have shuffled in. Anybody not get their test back yet?
Well, I was gonna start doing some better stickers.
So is there a variable now that will die if I add them together? Yes. Do not add them together if nothing will die. Does that make sense?
Yes.
I have students do that and they're like, what do I do now? I don't know. So again, I don't have to do anything to force something to die because those x's, they just want to die. So when I add these together, they're dead. And here I get 5y, 20. So y is 4. And then if I plug it into either one, it doesn't matter because the answer is where they agree, so it doesn't matter which one I use. If I plug 4 in for y and solve, I get x is 1. I did that kind of fast because you guys should all be able to do that. So the answer will be 1 pole. 1 pole. Alright. Now I see a lot of concerned looks up there. I don't know if I'm misreading your face. So if you're concerned that you should not ask a question because everybody understands this, you're wrong. You should ask the question. So any questions at this point about this method, the elimination method? So what I'm doing, like real quick, guys. So any method I use, I want to use both pieces of information together. I have to because I have two things I don't know. So the substitution method, guys, I rewrite one of them using the other one. So I use both of them together. Here, I'm very directly just putting them together. Both pieces of information, I'm putting them together. Oh, because 5y equals 20, so divide by 5. I mean, once you do it, then you just solve. The 1? Oh. If y is 4, I can plug that value back into either one and solve for x. So I plugged 4 into the first one. You guys see that? Once I know what y... Guys! Hey, everybody. Once I know what y is... I've got 100 students in here sometimes. I don't need everybody talking. Once I know what y is or what x is, I plug it back in and I solve for the other letter. Where do I plug it back in? I don't either one. Because they should both agree. It's going to be the place where they agree. So, is everybody cool with the y equals 4 piece to this?
Yes.
Okay, that was just, it was already set up that the x's had the same coefficient, different signs. They're going to die. I let them die. And I figure out what y is. Once I know either letter, here I know y, I plug it into either one and solve for x. So, what do I get if I plug it in the other one? I better get the same damn answer. So everybody cool? I used this one. I used this equation just now. But what if I would have used this equation? I would have had negative 5x plus twice 4. Right? I would have put a 4 in for y. And if I go to solve this, this would be negative 5x plus 8 equals 3. Subtract 8. Negative 5x equals negative 5. I would still get x is 1. You guys see that? It doesn't matter which one, because the whole idea is the answer is the point where they both agree. So who cares which line you use to get the other answer? In fact, that's the way you can check your work. You better get the same answer for each one, or else you did something wrong. All right. So far, the method itself is really decently easy if there's already something that's going to die when I add them together. So what about... Well, this is still a nice one. So the y's would die.
Number 4.
Let's look at number 4. Which letter is already different signs? The y. And then it's like an LCD sort of idea. I almost hesitate to say that because some of us are like, anything related to fractions makes things harder. But really, what do I multiply the first equation by so that the coefficient of the y is the same?
3.
All right. I love it. So everybody see that. If it's not the same already, I got to multiply one or both of the equations So I make them the same. It sounds a lot like LCD. So if I took the first one, and multiply by 3, what do I end up with? 6x plus 9y equals 0. Careful. 0 times anything is 0. So if you need to show yourself the work, you can go 3 times 2x plus 3y equals 3 times 0. So you get 6x plus 9y equals 0. Now rewrite the second one here. Leave the second one alone. It's already got a 9 there. And now I do like we just did. I combine them because now the y's will die. So try to finish that problem out. Yes?
Where do you got the tree from? The tree that you multiply?
Because I knew, so right now if I add them together, nothing cancels. And I don't get a better equation. A better equation would be one with less unknowns. So I want to add them in such a way that one of the variables cancels. That will not happen right now. 2 and 4 is 6, 3 minus 9 is negative 6. That doesn't get me anywhere. But if I triple that first one, and why am I allowed to do that? I can freaking triple both sides of any equation I want to. You guys understand? There's equations I would not do that to, but if I wanted to, I certainly could. Why do I want to triple that side now? Because that would make the y's 9 y's. And then they would cancel with the other 9 y's. Yes?
Could you divide the second one by 2?
Yeah, but then you make 4/3 x. You could, totally. I love it.
So you can double it and triple it, anything.
Of course, you can multiply both sides of an equation by almost anything. The only thing you cannot multiply both sides of an equation by is 0. Because then everything in the universe would be 0 equals 0, we'd be living in caves, it'd be crazy. And you're all like, that'd be awesome. No math, oh, screw that. So now, when you add these together, what do you get? 10x equals negative 12. Ooh, yummy. It's too bad. There will be fractional answers to some of these.
Divide by 10.
Divide by 10.
X equals negative 6.
So do not believe that you are wrong just because you got a fraction. There's still a chance you're wrong. But it's not because you got a fraction. You guys with me? Okay. So now, how do I get y?
Plug it back in.
Plug it back in. I'm going to use the one that's equal to 0.
Yeah.
So we got 2x plus 3y equals 0. So now I can use this information in here. Whoa. So x is negative 6/5. So twice negative 6/5 plus 3y equals 0. I get negative 12/5 plus 3y equals 0. So then I can add 12/5. 3y equals 12/5. And then what's the last step? I know when fractions are showing up, everybody just blanks, but I treat it as a number because that's what a fraction is. It's a number. So I want all my numbers on the other side. I don't care that it's a fraction. Who cares? Now I care that it's a fraction because what do I have to do to get y by itself? Divide by 3. And when I divide by 3, that's the same thing as multiplying by
6.
When there's a fraction, it's better to think of it that way. I don't want to put 12 over 5 over 3. Holy shit. I don't want fractions inside of fractions. And what happens to this guy?
You can cross
Yeah.
cancel 3 and 12.
So I get 4/5.
Can we see what x is equal?
Now again, if the fractions are what is troubling you, all right, that's one thing. Do you understand the method we're learning right now? And then you have to continuously try to get yourself better with fractions. It ain't going away. It's just a part of life. So the first thing I did, I'm told to use the elimination method, so nothing would eliminate at the moment, so I have to multiply one or both so that something will cancel.
I feel like
All right, let's do a couple more. You guys are like, is there a degree I can get where I don't have to take it? No, too bad. No, there's not, because it's got to mean something. My God. Oh yeah, this is a kind of a special case, but let's see. All right. Let's hold off on that one. Because I want to. Look at number 7. There we go. Now you could kill the x's or you could kill the y's. I sort of look to see what's already opposite signs. Stay with me now. Because if they're not opposite signs already, I have to multiply one of them by a negative. And anytime I have to do something with negatives, that's another place where I can make a mistake. But the x's have smaller numbers. So there's a bit of a trade-off there. So if I wanted to kill the x's, what would I have to make both the coefficients become so that they can kill it? I have to make them become 6. And you guys see now what I mean by it's like an LCD. What's the LCD of 2 and 3? 6. So I can multiply the first equation by 11. You can multiply. You got to multiply one of them by a negative so that they will actually cancel when you add them together. You guys, I love you guys. So I could. There's many ways I could do this problem. I could multiply this one by negative 2. And what do I get when I multiply that one by negative 2? I get negative 6x, good, plus 8y equals positive 44. Let me just stop right there. Just that by itself. I just multiplied both sides of that equation by negative 2. Completely legal.
oh, we have to do the extras.
Aw. Now, I've already got the x's opposite signs. What do I multiply the second one by? By 3, so that the x's will be the same coefficients, different signs, so they'll cancel. Now again, just to remind you guys, my goal at first is to make sure that it looks like something like this. Remember this? This is beautiful. Remember these times? Oh, like 5 minutes ago? Where the x's were already going to die. I didn't have to do anything. So the new step we're adding on right now is make sure that you get to a place where that's going to happen. So the x's will agree at 6. So I can kill the x's by making one of them negative 6 and one of them 6. So if I multiply this one by 3, what do I get? 6x.
It's 15y.
15y.
Equals 48.
48. I love it. Poor lady, dude. What? So all I've done so far is multiply both of the equations by something. I want to specifically make it so that the coefficients of one of the variables match up. And one of them's negative, one of them is positive. Because now what will happen when I combine them?
The x's cancel.
The x's cancel. So if I add these together, those go away. Here I get 23y, 92. And thank God, 23 goes into 92, believe it or not. 4 times. We're not done yet. Yes, ma'am.
When you plug that back into an equation, do you use the equations that you changed them into, or can you use the original ones?
When I multiply that equation by negative 2 on both sides, it's the same equation. It has the same answers.
No. When you plug y back, hold up.
There you go. I answered your question.
Sorry.
It doesn't matter, but of course I'm going to use the one that's got smaller freaking numbers, right? You could plug it back into one of the ones with the 6 x's in it. You could totally, and it's going to come out right. But I'd much rather plug it into something that's got smaller numbers. So yeah, plug it back into the original.
Okay.
It doesn't matter, again, it doesn't matter which one I plug it into. So I know y is 4. So if I do the second one here, which is 2x plus 5 times 4 equals 16. 2x plus 20 is 16. 2x is negative 4. I'm going to do this really quick. X is negative 2. Bam. Bam. So the answer would be now, could I have done this and killed the y's instead? What would I have multiplied the first one by to start to kill the y's? By 5, because the LCD between the y's would be 20. And again, I know it's not a denominator, so I could call it the LCM, but you guys aren't as familiar with LCM, least common multiple. What's the smallest number that 4 and 5 both multiply up to be? Frickin' 20. So I can make both of them have a 20 in front of the y. They're already opposite signs. You guys, it's a silly question I was about to ask. I was going to say, do you want to see? And you're like, I didn't want to see what you did already, but I'll show you. I'll show you. If I would have done this whole problem that killed the y's first instead. Okay? Like you said, what would I multiply the first one by? I multiply the first one by 5, and the second one I'm going to multiply by 4. So they both end up with 20s. One has a negative 20 and one has a 20, so that letter will die. Remember, both substitution and elimination, they say, oh, there's too many freaking letters. Let's kill one of them. One of them substitutes something with the other letter in it for that letter. And the other one just directly says, I'm going to kill it, right? But they both address that issue. There's too many unknowns. Let's get rid of one of them. So if I multiply the first one by 5, what do I get? 15x minus 20y. Just to cut to the chase. And if I multiply this one by 4, well, I left my x out, didn't I? I get 8x plus 20y, of course. You guys see that? The nice thing is there, again, they're already opposite signs, so I don't have to multiply by a negative. When I add these together, what do I get? So I get x equals what? Holy shit. Same thing I got before, of course. And then if I plug negative 2 back in, I am going to get y equals 4 the same way. So it does not matter which letter you pick to kill. You can either pick the one that's got the smaller numbers, or you can pick the one where they're already opposite signs. There's a reason for both of those approaches. Or you just pick the one that you see what the hell to do something with. That's a good option too. Is that nice? You guys look a little beat up. What about number 6? The y's are already opposite signs, but there's no way in hell I would do the y's. You guys see why? If I do the y's, I have to multiply both of them by something. And I have to figure out what that thing is. Oh, shit. If I do the x's, I only have to multiply one of the equations by something. Right? The first one's x plus 9, the second one is 2x. So what do I multiply the first one by? Negative 2. I mean, you guys start to see the idea. Pick a variable. There are reasons you could use to pick a certain variable over the other one, but it really, really kind of doesn't matter because the work will still come out. So I'd much rather do the x's because then I only have to multiply one of the equations by something. If I did the y's, I got to do an LCD kind of thing. I'd rather not. So what do I get when I multiply the first one by negative 2? Yeah, I get negative 2x. Keep going. Minus 18y equals.
-2.
The most common mistake is to forget that poor little dude on the other side. You got to multiply both sides of the equation by something. And the second one I'm going to leave alone. So now I've got it set up so that when I add them together, I actually lose a variable. So what do you get when you add these together? X's die. What's negative 18 minus 6?
Negative 24. And you get 8.
Yeah, so this is another yummy one. Y equals, careful. I know the optimistic part of your brain says negative 3. But the bottom's bigger, so it can't be a whole number. Y is negative 1/3. I don't know if you guys see this, but I'm not concerned. Now, I was waiting to see if anybody would shout this out to me. Because somebody asked this question earlier. But you see how I could have actually taken this one and cut it in half?
Oh, you did.
I like it. I'm not beating anybody up. That's something that's really easy to miss. I'd still have to multiply by a negative also. Do you guys see that? So if you miss that, who cares? Doesn't matter. Yes?
Well, to go along with that, the cutting it in half, for number 8, when she cut it in half, it came out to something, but then when I multiplied to get the negative, it...
Oh yeah,
every
it's a special
okay.
case. Well,
Okay,
that's
sorry.
why I skipped that early one too.
Okay.
So now we got to figure out what x is. We're not done with this. So we got x. If I use the first one, I get x plus 9 times y. And this is why I'm not too concerned about the fraction, because
Multiple.
3 goes into 9. Even if you use the other one, 3 goes into 6. So 3 goes into 9. 3 times, I get x minus 3 equals 1, so I get x is 4. So once you get one letter, you plug it back in, either one, to get the other letter. No matter what method you use, to be honest. Okay. Can't read any of that. Okay. So, you want to look at number 8 then?
Yeah.
We got so much time left, you guys are like, man, that clock can't be right. Yeah, I switched it earlier. Okay. So you guys might realize what's going to happen here. Maybe not. See how the x's are already different signs? What do I multiply the first one by? Multiply by 3. And you can use whatever notation. This is just the notation I tell myself. So what do I get when I multiply this by 3? I get 6x minus 15y. And when I add those together, I get 0 equals
0.
Is that a true statement?
Yes.
Yes. So there should be an infinite number of solutions. Anyone remember the correct way to say what those solutions are? It can't be all real numbers because the answer has to be points. No. No. I really want you to understand. The answer to a system of equations is a point or points. They're all the points that lie on that line. Because where do the points meet? On the line. So the answer to this is all points on 2x minus 5y equals 10. Because when you get 0 equals 0, that means they are actually the same equation. So when you graph them, won't they line up with each other? So where do they meet? At every point on that line. So that's the answer. The answer to a system of equations is where the lines meet. If they meet at every point on the line, that's the answer. You just said the answer because the answer is where they meet. So saying there's an infinite number of solutions, you're right, but you haven't told me what the solutions are. Does that make sense? So some teachers say, just put infinite down there. But that's not the answer. The answer is that, all points on there. That's the answer. That's what the points that work. You guys look so concerned. Okay. So here, let me let you guys do one out of here. Yeah. Here, do these two, number 5 and 6 on page 92. I'll give you a nice one and then a harder one. 5 and 6. Page 92. You guys can definitely help each other out if you want to. In the dark, you're working. One way to see it. I don't think I really need that mic anyway.
No, do it.
I'd probably blow the speakers out. I would forget I have it. Wow! All right. Let's take a look. this is already set up for the x's to cancel. So I just go ahead and let that happen. I just add these together, so I get
Negative 2y.
negative 2y equals 4. Y is negative 2. So then I choose either one I want, so I'm going to use this first one. 3x minus 4 times y. So 3x plus a is 11, minus a minus a, 3x is 3, so x is 1. And if you want to, you can write that as
1 negative.
Alright. What about number 6? Which way did somebody work that one out?
Multiplied by
4 negative 3.
I like it.
negative 3.
So you multiply this one by 4, sure.
Yeah.
And you multiply this one by,
Negative 3.
so that the a's will meet at 12, and they'll be opposite signs. You could have multiplied by 5 and negative 2 to make the b's meet at 10 with opposite signs. I mean, you got some flexibility.
Yes.
So when you multiply this by 4, you get what?
12.
12a
minus 8b
minus
equals 8.
8b equals 8.
Negative 12.
Negative 12a
Plus 15b
plus 15b.
plus 6.
6.
7b.
So then these cancel. 7b equals 14, thank God. These two. And once you have one letter,
Plug it back in.
plug it back in to get the other letter. I'm just going to use this one here just because I can get to it easier. 4a minus 5 times 2 is negative 2.
4a.
4a minus 10. A is 2. Second. How do you check your work? Yeah, plug it back in. Yeah. You can plug that back in. Now, if it works in the first one, it might not be the right answer. Because there's an infinite number of things that work in the first one. So you got to check both of them. So in the homework, there are going to be a couple problems that say, is this point a solution to the system? Don't just plug it into one of them and say, oh, it looks good. You got to try both of them out. It's got to work in both of them. That's the whole idea. Ooh, look at that. I still got 5 minutes here. Oh, all right. Let me do the silliest word problem in here. This is page 82. I love it. It's sort of like when somebody asks me, what do you do, Jeff? And I'm like, I teach math. And I always get like, oh. And then I say, okay, now word problems. I hate these. Oh well. This one is really quite silly. I can almost forgive the person that forgot how much money they put in their bank account. That's still pretty bad. It's like, dude, you got too much money. But here's the farmer that's forgot. Somebody knows there's 62 freaking legs out there, but he has no idea how many actual animals. So we'll just deal with that. All right. Now watch. This is so beautiful. What are my unknowns?
Ducks and cows.
Yeah, the number of ducks, number of cows. I'm going to call the number of ducks D.
Ooh.
And I'm going to call the number of ducks, the cows, W. Because then it's really easy to know what the answer means when you get the answer. If D is 7, I got 7 ducks. Hey, sweet. You got X is 7. What the shit's X? So there are 2 equations that they've told me. The first sentence is an equation. What's the equation? Yeah, D plus C is 24. Now, please tell me that you know how many legs. Now, we're going to assume that all these animals are healthy. None of them have any amputations or anything. You guys, they weren't born with an extra leg or something. Right? That's a good assumption that we have to make. In which case, for every duck, how many feet, how many legs would that duck? 2. So if there were 10 ducks, how many duck legs would there be?
How many ducks? 10?
10 ducks.
20.
There would be 20 duck legs. Well, how many ducks are there? D. So how many duck legs are there? 2D. So there's 2D duck legs. How many cow legs are there? 4C cow legs, for a total of 62 legs. Now again, you could divide this by 2, but let's pretend we didn't see it. What would I multiply 1 by?
-2.
Yeah, -2. All right, now, so I want to make sure. We have to set up our own equations. That's why word problems are difficult. It's because we have to create our own equations. So I agree with you. They are not the easiest things in the world. But these kind of set themselves up almost. The sentences go directly into equations. This is a very classic problem. It's called a total problem. I know a total of something, so I'm going to have variable plus variable equals total. And then I know each thing contributes, in this case, so many legs or whatever. Okay? So if I multiply this by -2, I'll get -2d minus 2c is -48. So when I add these together, I get 2c equals 14. So I have 7 cows. So how many ducks do I have? 17 ducks. Because there are 24 total animals. Right? Now, of course, in this case, you've got like 7.3 cows or something. You have to understand something went wrong. Right? Don't just leave that, 7.3. I'm like, what the hell up with that 0.3? Mutate? I don't know. All right. I think that's funny. I'll see some of you guys here in a minute in the lab.